All right, so let's talk about properties of definite integrals before we actually learn how to calculate one. Now, all of this is pretty straightforward, but I do want to draw some pictures so we can see what's actually happening. So, first one here, the definite integral from a to a of f of x with respect to x is equal to 0. What that means is that if you have a function that looks something like that, or it doesn't matter what it looks like, and you want to find the area under the curve, but you're putting just like that's an infinitely small area. So if you do it between a and a, your answer is going to be 0 because it's an infinitely small area underneath that single line. Okay, this next one looks more complicated, but it's really not. It says the integral between b and a is equal to the integral between c and a and b and c. So what they're saying is, I'll just draw it here. If I have b and a, the integral, the area under the curve between b and a, will be equal to the area under the curve CA and BC, adding those two areas together. That's why it says if A is less than C, which is less than B. They're in that order. Okay, next up, if you have a function multiplied by a constant, the definite integral of that's going to be the same as the constant times the definite integral there. So if I was to use an example, I can say that the definite integral between 3 and 1 of 4 sine x is equal to 4 times the definite integral 3, 1 sine x. So same thing, put those brackets there, not really needed. Okay, next up, it says the definite integral between b and a of f of x plus g of x with respect to x is equal to the integral of the first function with respect to x plus the integral of the second function with respect to x. So example, let's choose some funky ones. So the integral between 4 and 1 of sine x plus 1 on x is equal to the integral between 4 and 1 of sine x plus the integral between 4 and 1 on x. I should be using with respect to x there, with respect to x there, with respect to x there, with respect to x, with respect to x. Okay, and this brings us to our last one. I said your higher number needs to go at the top. If you don't put your higher number at the top, it's not a disaster. It just means that your answer is going to end up being negative. So when we do this algebraically, if you go the integral between, well, how can I say this? Well, actually, let's save that for another video. For now, all you need to know is that if you mix up your numbers, you're going to get a negative answer when you should have gotten a positive answer. So there's the properties of definite integrals. We still haven't looked at how to do them algebraically, but that's coming up next.